Historically, Sony have always followed their main PlayStation console launches with slimmer versions about 3 to 4 years after their initial release. As their latest console, the PS5, is literally their largest ever, a slim version is sorely needed. But as it's so new, I think it's unfortunately going to be a while yet until we see a more compact version. However, I think it's going to be possible to make the present version slimmer. How slim? That slim? Maybe that slim? How about 2 centimeters? And for context, that's a fraction more than the thickness of a DVD. As we discovered in my previous PS5 videos, stripping away its casing to get to the internal components is relatively straightforward, leaving us with the PS5's motherboard and power supply. As you can see, the power supply alone takes up quite a bit of space, and I'm really not sure what options I have to make it smaller yet, so I'm going to brush it under the rug to deal with later. Focusing on the main motherboard, the scale of the challenge remains, as this alone still measures about 5.5 centimeters thick, which is just over 2 inches. Remember, my target is 2 centimeters, so I've got quite a way to go, but thankfully most of this thickness comes from the cooling heatsink, which has given me an idea, though one that requires us to go deeper still. Off it comes. As you can see, the heatsink makes contact with the main processor, in this case an SoC, to cool it, as this is where the majority of the heat comes from. It's a lot of heat as well, almost 200 watts. That's as much as a slow cooker on high heat, but from a tiny surface area. This is presumably why Sony have opted to use a liquid metal to act as a thermal bridge between the SoC and the heatsink, as it's much more effective at transferring heat than traditional thermal pastes. As it's conductive to electricity as well though, I'll have to clean it off for now so that it doesn't spill onto any surrounding components in the meantime. Shiny. So with the steel shrouding and heatsink removed, things are looking a bit more promising, as the motherboard itself is surprisingly thin. We're not out of the woods yet though, because turning it on in this state would mean that it would obviously just instantly overheat and die. So we need to figure out a way of dealing with all of this heat, but in a much slimmer form factor. We can look towards desktop computers for some inspiration for this, as a common compact way to cool their processors effectively is to use water cooling blocks. These are simply mounted on top of heat generating components, allowing water to be pumped through them to wick away the heat. While they are much smaller than heatsinks, this advantage diminishes somewhat when the tubing is attached, as even when bent over, almost 6 centimeters of headroom is still required, with right angle fittings not improving matters either. So, a little creativity is in order. You see, while the top part of the water block is an important functional component of it, it's actually the copper base plate that does most of the heavy lifting. This has many small channels cut into it to increase the surface area in contact with water at any one time, drastically improving thermal transfer. As you can see, this in itself is pretty thin, and so long as we can get water to and from it effectively, we might be in with a chance here. So my plan is to build a custom water channeling system with a new material for me, copper sheeting. Sorry, brass. I've got 3 thicknesses here in order to make a copper sandwich, with the middle layer being the thickest at 3mm. For some reason, copper in sheet form is ridiculously expensive, and these sheets alone cost almost as much as the PS5 itself. So a big thank you to my Patreon supporters who donate to the channel to keep me making these crazy projects. You guys rock. Now the first step in making this custom channeling is to trim down the first layer with a slot to fit around the various ports. Well, we've already hit our first snag. The power connector that fits into the power supply is rather tall, so that needs to go. Much better. Now it's vitally important that the cooling block touches the PS5 processor directly, which means that it's necessary to cut out a hole for it in this first layer, refining it to the correct shape with a file. Despite this, the rather thick rim of the block still pushes the fins too far away, preventing them from being flush with the rest of the copper. So it's time for some more cutting. No going back. Perfect. There are 3 components that still impact this layer, stopping it from lying flat, but they can be dealt with by drilling a few holes. Speaking of holes, now that this layer does lie flat, it's possible to mark where the motherboard mounting holes are in order to add some brass pillar supports for them. That these are brass is not a coincidence. They need to be made watertight, and to do this I'm going to solder them to the copper itself with a blowtorch. These have thankfully ended up accurate enough for the motherboard to rest on them fairly loosely, meaning that there shouldn't be any pressure when it's screwed on properly later. Now, in order to direct the water from the intake to the cooling block and then round and out again, we're going to bring into play the middle copper layer, which, if you remember, is twice as thick at 3mm. The water channel is going to be cut from this, with the path I've sketched out following the same route, in through a hole to the cooling block and then around and out again. Now, the reason why I'm utilising layers to make these channels is exemplified here, which is solely that it doesn't need any fancy equipment or CNC routers to make them, just a good old jigsaw with a metal blade attached. I also need to make a much smaller channel adjacent to the larger one, which will be for cooling an additional component that I'll be tackling later. So here we have the finished article. When it's mounted to the 3rd layer, which will simply be a blank lid, water will be pumped over the CPU, round and out again, with a small amount of water entering the micro channel, in and out. So we've now reached a pivotal moment in this project, which is to solder these layers together to make them a single watertight chamber that can then in turn hopefully cool the PS5. Now, my original plan for this was to simply use the blowtorch, but thinking about it, the actual heat output of this is very focused, which means as I heat up an area, another area is just going to cool down, and I don't think that this thing has enough power for it to heat the whole thing if I were to move the flame over it rapidly. So I need an alternative plan, and this comes in the form of a little oven. Now, my thinking here is to tin the individual layers, put them in the oven, which will hopefully heat them up enough to melt the solder, welding them together. But I'm not actually sure whether this thing can get hot enough yet, so let's start with some tests. The first thing I'm going to do here is prepare 2 pieces of copper by tinning them with some solder, and then some crocodile clips can be used to clamp them together. These put a constant squeezing pressure against both sides, which should be helpful when the solder melts. Now, it's worth noting that I've bought this oven specifically for this project, and it will not be used for food here on out, because the solder fumes can be pretty nasty. Anyway, after about 15 minutes, the bit of solder on top suddenly melts, which means that the oven does indeed get hot enough. How about the strips? Well, now that they're cool, I can break them apart, but we can see that the solder has definitely fully melted between them as well. So this method definitely has a chance of working, so it's time for the real deal. This again requires the layers to be tinned on both sides before putting crocodile clips around the perimeter. As you may have noticed, I'm doing the bottom and middle layers first, just in case something goes wrong. But success! It's a bit gooey from the flux, but the 2 layers are definitely joined together now. One thing I realised though is that it would have been all too easy for the mini channel to have filled up with solder, which would have blocked it. So to protect it from the next batch of soldering, I'm filling it with a type of silicone grease. I've had this stuff for years as a cheap thermal paste, but from my experiments it resists these temperatures well enough, and more importantly it dissolves in alcohol, so it should be easy to remove afterwards. As the middle isn't being squeezed by the crocodile clips, I'm wedging in some metal to provide some central pressure. And there we have it. One custom PS5 water block made with hand tools, and as you can see it now features some barbed inlet and outlet ports which I soldered in place separately for attaching some tubing later. To get the grease out, I'm using a syringe to force it out with the alcohol. As I've bunged up the main channel, it has nowhere to go but through the small channel, which is why it's very stubborn, But after soaking it for a few hours, it finally bursts free. This needs to be done several times before the alcohol runs clear, after which I can follow it up with a diluted acid mix to clear out any of the remaining flux from the inside with the help of a water pump. Now, as you can see, there is one part conspicuously missing here, which is the cooling block. I've left it out until now, again for fear of the channels getting filled with solder, and I'm using the last of the grease to jam these full of it to hopefully prevent solder from taking its place. And again, once all of the grease and gunk has been cleared out, it's the moment of truth. Is it watertight? Yes! Mission accomplished. Okay, so with this soldered up, I'm actually feeling really good about this project because not only do we know that this is now airtight, which in turn makes it watertight as well, but I'm also fairly confident that the water block itself hasn't filled with solder. If it had, it would have been game over, so I'm very happy about that. But as you can see, it looks extremely messy and not very presentable, so I think we need to give this a polish and then we can fit the PS5 into it. So let's go. I'm not going for a pristine finish here, as it's really only an internal component and won't ever be seen, but even so, it's turned up looking pretty cool. Before I can mount the motherboard in place though, there are a few additional thermal bridges that need to be made. You see, on the original cooling system, the steel plate made contact with a few secondary heat generating components, namely some flash storage and some power circuitry. Making sure that these components get access to the cooling ability of the water block will ensure that they're kept as cool as what they were designed for, maybe even cooler. And to do this, I'm simply using some copper strips and thermal glue, with the accompanying components receiving standard thermal paste to prepare them for mounting. As for the SoC, that needs a new coating of liquid metal for better thermal bridging. And to prevent overspill, I'm tracing its perimeter with putty to seal around it, much like on the original heatsink, with the same being mirrored on the copper side. To ensure that it makes good contact, I'm using the original rear bracket to put downward pressure on the back of the processor, and in addition to that, there are some components on this side of the board that also need some thermal bridging, though this time to a lid that I've not made yet. These aren't particularly power-hungry components, so having the heat dissipated to a lid should be quite adequate for them. But this isn't the case at all for the VRMs, which are in a row right here. These regulate the power input, and as a result, they generate too much heat to be dealt with passively by the lid. On the original PS5s, Sony kept them cool by using a heat pipe to link them to a small heatsink. A heat pipe, for those who don't know, isn't just a rod of copper, but is actually hollow with a wick covering the internal surface. As there's a liquid inside that has a low boiling point, this liquid evaporates from the wick whenever heat is applied and then moves as a vapour to cooler areas where it condenses again before soaking back into the wick where the process starts all over again. This moves heat rapidly and effectively, but the shape of the original won't fit my new design, so I'm going to have to make my own. Thankfully, it's fairly easy to buy brand new heat pipes online, and after warming it up, it's possible to bend it fairly easily into the required shape. What's not so easy, however, is soldering heat pipes to anything, as if you heat them up too much they can explode. Cooling one side with a damp cloth though worked for me, and I was able to mount it to the original copper spreader. All this, by the way, is what the additional mini water channel is for, as it cools a stack of copper, which in turn cools the heat pipe. And with that, all the thermal bridges have been made, and it's looking pretty slim. But there's a big problem that could spoil the party. Where's the power supply going to go? As you've seen already, it's kind of big and a bit of a weird shape, and it begs the question, where have Sony put the power supply in their past slimline consoles? Well, in the past two PlayStation Slim releases, they drastically lowered the console's overall power consumption, which meant that their internal power supplies could be much smaller, though capable of delivering far less power. Unfortunately for us, there's no way we can reduce the PS5's overall power requirement to allow the use of these smaller power supplies, but there is still one option we can explore which Sony and other console makers have resorted to in the past, making the power supply external. Both the PS1 and PS2 Slim offloaded power to an external power brick to make them smaller, a strategy also used in several Xbox consoles as well. While it's not ideal, we are trying to push things to the extreme here, so it's a compromise I'm willing to make. In order to prepare for this, I need to solder some really thick wire to the PS5's power input to reduce the voltage drop down its length, and routing it around to exit between the barbed connectors allows me to hide it between the two lengths of rubber tubing that will carry water to and from the cooling block. This stuff is a bit thicker than I'd like, but at least it's nice and robust, and to match it aesthetically with the rest of the build, I thought it would be cool to sheathe it with some copper braiding, which also provides grounding to the chassis. So with that done, we're ready to add the lid. Earlier I used the cooling block as a template for making this, using the last bits of copper and soldering them together, which ended up looking pretty neat. While I am going for a minimal look here, I do need to make some holes for the USB ports, and also for a power button. As I want to make this power button also act as a power light indicator, we can take the PS5's original lighting strip board and glue a brass tube over its LEDs with some epoxy. The LEDs should light up this epoxy, which will be visible through the tube, but we'll have to wait until later to see how well this works. As the LED board itself doesn't actually feature a button of any kind, some glue can be used at the other end to anchor it, so that when pressed it can trigger a little push button mounted behind it like so. This push button in turn is wired up to the original power button and will thus trigger the PS5 to turn on or off when pressed. As I earlier soldered some brass pillars to the internal corners of this cover, it can be screwed in place from underneath, with some rubber pads providing some feet here as well. To tidy up the rear side, it has its own special cover, and to make the tubing look a bit neater, I've used my trusty prusa to print off a few plastic brackets to clip it at various points, essentially turning it into a tether. Despite being fairly bulky, it's not really that noticeable when the unit is in position, especially as, like most set-top devices, it will have other cables like HDMI going into the back of it anyway. Either way, it looks great in my book, and the polished copper provides a unique, refreshing aesthetic. The best bit, of course, is that it measures just 1.9 centimeters. We've actually beaten my 2 centimeter goal, and it's now a fraction of the thickness of the original. Crazy. Before we can turn it on though and test out whether the cooling block performs well enough to keep the system cool during use, I do still need to sort out a power supply, which, as you know, is inspired by previous PS5 Slim releases. The only difference with mine is that it's going to have to handle cooling as well, which makes things challenging but also very interesting. But before we get on with that, one thing you'll notice with this build is that it's taken a lot of time and effort even just to get to this point. And even though I've mostly used hand tools, I doubt that many of you are going to put the time and energy into copying what I've done here. But that's okay, because making your PS5 slimmer and cooler isn't actually as hard as all this, which leads me neatly onto a quick ad from the sponsor of this video, Dbrand, who make what they call Dark Plates 2.0, which are replacement PS5 side panels with some awesome new features. The most apparent being that they have a built-in vent which improves airflow to the fan, resulting in more effective cooling. Mounting them is as simple as clipping them in place, and as you can see they give the PS5 a completely different aesthetic thanks to their new shape. I'll be honest, the PS5's original protruding collar has grown a bit old in my book, so it's great to have a smarter alternative, especially as they're available in different tones. Now, I'd imagine that redesigning these panels from the ground up was a huge challenge, but Dbrand's efforts have certainly paid off because the quality is just as good as the originals and they fit perfectly. Now, if you want even more customization options, Dbrand's got you covered there as well, as they've got a variety of high quality vinyl skins that can be used to easily change the appearance and texture of the central glossy plastic. And they have the added benefit of being much more resistant to fingerprints and scratches, something the original gloss finish was very susceptible to. And their cool light filters are something else entirely. So visit dbrand.com/DIY dark plates if you'd like to customise your PS5 to put your own style to it. And don't forget that dbrand offer skins for all sorts of other devices too, for you to make them your own. So thank you dbrand for sponsoring this video, and let's get back to the project. So with these tethers now added, I need to make a power brick that can not only provide power for the PS5, but also cool it as well. Now in terms of power, the power brick that was originally inside the PS5 is not only a super weird shape, but it doesn't feature its own fan, instead being designed to rely on the console's own airflow to keep itself cool. Strapping a fan onto it to keep it cool just looks stupid, so ideally I'd like to get rid of it and use something else entirely. Taking a close look at its specs, we can see that it outputs 31 amps at 12 volts, and thankfully it appears to present this voltage without being connected up to the PS5. So, in theory, we can indeed swap it out with any sufficiently powerful 12 volt alternative. I have this much more sensibly shaped computer power supply on hand that'll do the trick. And to make it a bit prettier, I've made a case out of aluminium to go around it, though you might be wondering why it's so long. Well, that's to make room for the cooling components, which have been provided for this build by AlphaCool, the main one of which is this slimline cooling radiator. After adding some fans to push air through it and a set of water pumps to circulate the water, it can be fitted to the casing alongside the power supply and be linked up to the PS5's new tubing. Now, as is normal for water cooling loops, it needs a special type of coolant, and I'm using a temporary reservoir to make filling it a bit easier. As the copper of the main PS5 body and the aluminium casing of this power/cooling unit both block Wi-Fi signals, I've extended the antennas down to be glued to the exterior of this for an unobstructed signal. While it's not the prettiest thing in the world, it actually won't ever be seen, as the idea is for it to mount to the wall behind a TV. And with that, the unit is complete and we're ready to test it out. Now, it would be a little bit of an understatement to say that I'm nervous, because I've worked on this for a couple of months, and let's hope it works. Come on. Okay, so 12 volts is being supplied to it as expected, but there is one thing that I'm hoping is the cause, which is simply that the fan isn't plugged in. After all, I've had computers before that won't turn on without a fan, so maybe that's the case here as well. But unfortunately not. Look, it's going! Ah! What I did was just where the power lead goes in here, I just bridged the connection, so that's great because that's not that hard to fix. And we are now working. So what I've done is basically just bypass the original power button and its little strip and just solder it straight onto the motherboard, and it's working, which is great. Hey! That little beep of triumph. There we go. That's a relief. So, getting it turned on is obviously great, but the whole point of this thing was to obviously make it thin, but it needs to perform just as well as the original console in terms of keeping the PlayStation cool. So, step 1, turns on. Step 2, need to make sure it actually works properly. So let's run some games and see if it's kept cool. Little did I know that things were about to go horribly wrong. That's not good. It's frozen. Feels okay. Whoa. This isn't where this is going to be permanently fitted, so I had it propped up on this and it had fallen over, blocking the intake, which is on the bottom here, so there was no airflow, and the PS5 presumably overheated, so let's hope it's not done any permanent damage. Come on, I'm just fed up. We've got another problem. a bigger one this time. It's now not turning on. So the light comes on and then it just goes off and there's nothing I can do to change it. And to have made such a stupid mistake right at the project's completion, killing the PS5 stone dead, is devastating. So I am incredibly disappointed, but I'm not going to give up because dbrand actually sent over a spare PS5 to use for the B-roll for their sponsor spot. And I am going to borrow the motherboard from this to hopefully get the system running again. So sorry dbrand, if you're wondering where your PS5 is, well, here's your answer why you've not received it back yet. Anyway, the process of transplanting the motherboard isn't terribly difficult, but this time I'm including a few thermal probes so we can monitor the PS5's temperatures at various points to make sure it's all working within spec. So, with the cooling unit mounted more securely this time, it's the moment of truth. Light. Come on. Come on. Yes! Oh! Thank you, dbrand! At last. Woo! Now, before I do anything else, I'm going to test out the temperatures on this thing so we can hopefully avoid a reshoot of what happened earlier. So I'm going to run Horizon Forbidden West, which is a new title, and it should push the PS5 to its limits, but I'm going to be monitoring the thermals through my thermal probes, so let's hope it goes well. After leaving the game running for several hours, the first news is that it hasn't frozen this time, and checking out the temperatures we can start to see why. The main processor probe reports a maximum temperature of just 46 Celsius. As the probe isn't actually inside the silicon though, my best guess is that it's somewhere around 65 degrees internally, but still a good result. What about the memory? This one should be fairly accurate as the probe has been embedded within the heat spreader itself, and we get a result of 52 degrees here. The VRMs are even cooler at 44 degrees, indicating that the heat pipe is doing its job. Yay! So great results, but how do they compare to the original untouched PS5? Well, I positioned my thermal probes as closely as possible to how the guys over at Gamers Nexus mounted theirs when they were doing a detailed thermal analysis of the console, and there are some interesting findings here. Their processor measurement hit 75 Celsius, though again this was taken from the back, so it wouldn't surprise me if the actual silicon temperature was in the 80 degrees Celsius range at least. As for their RAM measurements, they reported that it hits 94 degrees Celsius, and that it's likely running a bit too close to its maximum allowable temperature. So the 52 degrees we're getting is really good news, as are the results for the VRMs. The original cooler, 71 degrees Celsius. The water-cooled PS5, 44 degrees Celsius. Cool. Literally. It's likely that we can get these temperatures even lower as well if we were to use a larger cooler, but that's a video for another time. So there we have it, the world's first PS5 Slim. I still can't quite believe just how thin we've managed to make this, and that it works better at keeping the console cool than the original cooler did, well, that's just an extra cherry on top. Now, of course, we did have a few setbacks, so a massive thank you has to go out to dbrand for rescuing this project by sacrificing their own PS5, although they don't know it yet. So make sure you support them by maybe buying some dark plates for your own PS5, or buying perhaps a skin for your smartphone. And of course, if you want to support this channel directly, you can do so at patreon.com/DIYperks, or maybe buy a cool t-shirt like this one, DIY Perks Fan. But other than that, I'm Matt, you've been watching DIY Perks, and I hope to see you next time. Goodbye for now.